So the focus today in this presentation is DevOps. It is definitely a buzzword, something we've heard about a lot, depending on what size company you're in. But even mid and even small size companies, there is a sense of DevOps in a lot of cases. And particularly when you get into the world of cloud, it really, you'll find as we're talking through it, it is well suited to a lot of the cloud related features, the pros and cons of working in the cloud. So we're going to give a nice little overview of that today. It's definitely an area that you can go deeper in. It's like Agile. It's one of these things that there are a lot of pieces. So you can say you do it, but you may or may not do different pieces of it. You may do it differently. It's definitely just, we're going to hit sort of the tip of the iceberg to try to get an idea of what they are and what things fall into the, under the umbrella of DevOps. And so we'll start with just a sort of a brief little sort of a definition, a little bit of the history of it, which you'll find is not very deep or long. What does it provide? Who cares basically about this DevOps thing? What does it do for us? And then talk about some of the practices, the methods that fall under that umbrella that are DevOps practices and methods, how it fits in with some of the various methodologies that are out there, and then sort of a pros and cons, benefits and concerns about DevOps and what you get out of it and what you need to be worried about with it. So definition, and this came, unfortunately, I forgot the link to where this came from, but I think it was off of basically on Wikipedia. But the word DevOps, it's a combination of just development and operations. So it's, as you would sort of guess what it means, that's what it is. It's development and operations, and it is where you have a collaboration between the developers and the operations side of software development. Developers are the ones that are building software. Operations are the ones that are basically deploying, maintaining, doing upgrades and patches and things of that nature. Sometimes it's configuration management back in the day. When we think about the waterfall lifecycle, software development lifecycle, we talk about there's a deployment step. That's typically the operations type people are taking that's what they own. In its broadest meaning, it is a philosophy that promotes better communication and collaboration between these teams. There have been historically, it's almost like a throw it over the wall approach where the developers do their stuff. They say, all right, I've got it on a development machine or a testing machine or something like that. And now we're going to send it off to the operations people and they promote it to production and they have to deal with it. Doesn't work super well doing that. So DevOps is a way to try to clean up that relationship and make it smoother. And along the way, do some other things like remove, make it less error prone, make it more streamlined, scalable, things of that nature. It also covers, the term DevOps also covers culture changes, that is how we change looking at the development team and the operations team. In some cases, they've been seen as vastly different groups that don't really, back to that communication thing, they don't really talk, they don't do much together, they don't interact much, or when they do, it's through a simple email or document or something like that. This turns this in, DevOps is more idea of like bringing those groups together so that there's much more cohesion from the beginning of creating software all the way through deploying it and testing it and putting it out to production, making sure that we've got the platforms and the places that we're putting these things, the servers and the resources match appropriately. And so that DevOps is sort of they help look at that and help the development team do a better job of moving their code out to testing and users, things of that nature. But because of all of this, DevOps includes, there's different roles, there's different approaches, there's different views, there's different best practices. And all of this will sort of, like I said, we'll touch on. You could spend days, there's DevOps conferences and such out there, You could spend a lot of time talking about it. We're going to try to cover it in a very short period of time. So brief history, which you'll find there isn't much more than a brief history of DevOps. It's a term that was essentially created in 2009 by Patrick Dubois. It was actually through a conference. It was the DevOps conference. And from there, it quickly has grown into, DevOps became something that was like, oh, that's a neat idea, to this is something we really want to use. It was embraced within the first few years by the ITIL champions, people that are into processes and reproducing software development tasks and promotion and deployment tasks. If you want to think of sort of a core document about DevOps, there's a fictional book called The Phoenix Project that came out in 2013, and it definitely it gives you sort of instead of the theory, it's, hey, here's how this would look. It's more of an application view of DevOps and how that should work in the real world. It's really been it's been embraced and sometimes is intertwined with continuous integration, continuous deployment, because definitely that you really almost need DevOps to do that, so that you've got people that own the CI/CD part of development, as opposed to like coders that are, or software developers that are writing stuff. They just don't have the time or the bandwidth a lot of times to do the integration and deployment piece. And so that's where DevOps has become more and more of almost a need. And when you look at Agile and rapid turnaround, if you look at cloud infrastructures as code and things like that, there are a lot of changes in the last almost 15 years now that have really helped push DevOps to the forefront and made it much more valuable, much more useful. If you go back 20 or 30 years ago, when you had essentially zero virtual machines, it was a different approach. And you can't use source code to create a physical hard server. If you've got VMs, you can spin stuff up and down based on code. So there's things like that just the progression of technology has allowed DevOps to become a thing, and a very useful one, and something that we probably do more often than we think. So with that, what does DevOps give us? How does that help us in our software development tasks? Now, DevOps, although it is not the same as continuous integration and deployment, it enables that. It makes that something that we can do. And it's really almost it really is almost a goal of DevOps, is to do that, is to have that quick and steady and continuous flow of code into some sort of a production type or a usable environment. It may not be production, it could be test, it could be some sort of staging environment, and something along those lines. And so when you have that, when you have things like either instantaneous or daily builds and deployments, then you're by nature going to have smaller and more easily reversible changes to the code. You're going to be doing smaller blocks of work, and you're going to be validating that within the bigger system on a regular basis. So if you do that, if you do daily builds, and with daily builds, it's implying that there is also some sort of regression test going on and things like that. So code is committed, validated, maybe reviewed. There's a regression test that goes through. Then it gets pushed out. And if not, if it fails anywhere, then you get a message back so you know that your little bit of code, whatever you worked on today, didn't work. However, you may get more or less details than that, but you know what broke it. You know it was the work you did today and not necessarily the work you did in the last 3 months or something like that. Or I guess it's the work you committed today. So it could have been work you've been working on for a while, but typically because of how DevOps pushes us as development teams, we're more likely to do more frequent commits, smaller sections of code, much more defined, and then that makes it easy to reverse, easy to pull it back out, and also easier to debug. And that leads to shorter cycle times from requirements all the way up to live software. Because much like we've talked about when we talk about agile and sprints, ideally you're releasing software at the end of every sprint, or every other sprint, or every third sprint, or whatever it is. But there's regular deployment. There's regular software made available to users. CI/CD is an even shorter cycle time. So you may have requirements, and you may see live software that's some pieces of functionality that are showing up within days. It gives us, DevOps gives us silos for development and operations, and really highlights that those exist. When we talked way back, when we talked about the waterfall approach, the waterfall methodology, that was one of the things, is you had these silos for testing, for development. When you got to deployment, it was a little murky because it depended on the size of software, depended on the environment. And a lot of times you would have the developers or the testers would also be essentially the operations piece. Or in some cases, operations wasn't even considered until after the fact. So you would go build software, put it out there to users, and then say, oh, crud, I've got to have some sort of support desk or something like that. And it wasn't really considered. Definitely was not part of development. It was just sort of this other thing that was like a add-on thing we do after the software is done. And what DevOps gives us is highlighting that these are roles that we need. These are skill sets that we need. This is experience that we need in these various areas. We're comfortable with, we need developers, but there's also operations that needs to be there, and we need to account for that. With some of the things that DevOps gives us, the ability to move quickly from like a development environment to a staging environment or testing environment, production, we have more realistic testing opportunities. Instead of developers just sort of creating their own little development sandbox, and they're playing around and doing stuff, and their code's not necessarily all together and up to date with everybody else's, and their test data may be completely wonky. Now you've got these environments that you can actually make them more real, for lack of a better term, but put maybe something that is much closer to mimicking what the production environment's going to look like, as far as like including size of data. If you're a developer and you've got to enter in data, you're not going to enter in more than a few records because it just takes too much time. But if you've got a team that's either, maybe the operation side has some data load scripts, or you just have a lot of people working on the system, you're going to get more data, and it's going to be different from what you would do as a developer. And so you have better testing opportunities. You get to test more against something that looks real when you're using DevOps. A key thing to all of this is that then it gets us closer to solving the "it works on my machine" problem, which you see a lot of times with developers, where they write their code, they do a build, it works for them. They can show you it works for them. They can show you exactly how it is. But then as soon as you put it to somebody else's machine, as soon as you put it to the test environment, it breaks. And because without DevOps, we don't necessarily know what the differences are between the development machine and the QA machine, and development in particular, because developers are famous for having a whole bunch of stuff on their machine in their environment that is not going to be there even when you go to the test or the stage environment. And those things can impact whether something works or not. So if you don't know what you have, if you can't define in detail the differences in the environments, it's that much harder to figure out why it doesn't work. The flip side, if you've got, go to the nicest thing, if you've got a script that builds your development environment, then that same script should be able to point to your QA environment and build that. And so you know then that the environments are, for all intents and purposes, identical. And that way, if it works on the development machine, then it needs to work, you know it's going to work on the QA machine, or vice versa. Or at the very least, you know that it's not a difference in the machine, in the environment itself. Or at least you've got a better starting point, I guess. So let's talk about some of the practices and methods. I've actually touched on some of these already, but I think it's good to sort of walk through them. And this may have even been one of those things that's sort of out of place in the presentation, but I think it helps to give you an idea of what the value is of DevOps a little bit and at a high level before we get into some of the specifics. So some specific things that you're going to find in DevOps. One is build automation. I've talked about this already, which is basically combined with infrastructure as code. Is DevOps is going to automate as many things and script out as many things as possible. When you think of, if you want to do a comparison, think about testing, is that there are manual testers and there's automated testing. And as you grow systems, you want more and more to be automated testing because it's not feasible to do manual testing with the frequency and the size that you want. DevOps is the same thing. When you get into operations where you're building out dozens, maybe hundreds, maybe thousands of machines or devices, or deploying out to them, you're dealing with maybe as many projects, millions of lines of code, and all these different complex build strategies and integrations and things like that. You want to automate it. It's not something where you want somebody, they have to run this script and they have to type this thing in, and they have to build this and they have to do this other thing. You want that done as a script. And there are a lot of tools that help us do this. You can look at Hudson and Jenkins and things like that have been around for a while that provide us these CI/CD tools, continuous integration and deployment, ways to commit software, commit code changes, and then have a process somewhere that's watching that and says, hey, I have a commit. I'm going to do a build, whatever that looks like. I'm going to check out the latest code. If there's merges or something, maybe it does it. Maybe it kicks back to somebody that says, hey, this requires a manual merge. It's going to do the build. It's going to run through some sort of test to say, yep, the build was successful. We built what we wanted to, and it roughly works. And then push it out to, deploy it out to some target, whether that's, it could be a development machine, it could be QA or even production.